in the distributed system, even if there are issues, I want to ensure that when people reach my application, you can see a response, even if it is not meet accurate data. I just want them to have a response. This guy availability is best. It works, right? So we want to ensure that all at all, though, if anything goes bad, let's see something. Let them not see 500 internal server error, or let them not see, unfortunately, your app is have died. All those things. You want to be able to ensure that your application is still there, serving its purpose, even if the data is serving. Well, might not be accurate. This guy are not tried in tech because they're not telling you that you have 1 million or you don't have 1 million. So you have to be able to pick well how to balance this there. And the last one is transaction tolerance. Transaction tolerance, by default, people who build should say, you pay about this guy because purpose of you having this parts, you can have multiple nodes, right? When the partition tolerance happens, when the partition network partition happens, which is failure to communicate between nodes, right? You want to be able to ensure that, oh no, this guy is still be able to communicate to this other one at all because it's a distributed system. It's not a single application. So by default, this guy is out of the option. Like they just pick it. They're now left to balancing. Do I want AP? Do I want CP? That's a question that everybody chooses next, right? So if you are building something today, what would you choose, right? What are you going to choose to favor? Which of these two are you going to pick? And this boils down to your application, nature of the application. Like I said, in fintech world, people would rather go for applicability and partition tolerance than consistency and that's why today you want to log into your banker. It's not, they work. And they know what they're doing. It's not because they're not able to save it at that time. It's because they want to keep you safe in some way. They want to ensure that the outage is still there, right? Outage is there, but you can control the response of the people, right? You don't want to open your bank app and see the balance that is not there, right? That is why you would now say, well, the application is down. Instead of me showing you inaccurate information, let me not just allow you in that this application. It's fine for you. They can improve all with that. So they would rather kick consistency or partition tolerance. And there's some people that will pick availability over consistency, like public people. People want you to open whenever there's google.com, whether there's fire catching their servers, they want you to be able to see google.com, right? And they don't really care about consistency because they can show you the data from 1 million years ago as support of T, right? So the nature of the application you're building really tells us, or really help you choose which of these things to pick. So in reality, most systems sacrifice consistency for availability, leading to conflict. Aside from this research, so my research was what I tried to do was try to look for how to ensure that when you're building a distributed system, you don't really bother about which of these. Just have a framework that caters for all of this, right? And I've done that, although we need more people to join in the research to ensure that, this is a very solid thing. And then, I already said consistency for availability, really benefit, blah, 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 blah. Fintech rules to choose availability, consistency, like I said. Availability, you might not see it because they don't want to serve you. That's that. So in this research, try to join two already existing concepts, right? And that's what I'm going to do today. Academia DHT. So in the course of my research, I stumbled upon this guy. I did not know it before. I have seen it somewhere. I think there was a time I was trying to apply for a particular role and they said knowledge of DHTs. And I'm like, I know these packs, HT. As a software engineer, most of us know what hash tables are, right? So I knew HT, but I don't know DHT. Talk less of KDHT. So where am I even starting from? I left the application and I went to research on DHT and I found this guy. Academia DHT. So what are DHTs actually? Distributed hash tables they represent the building block for the decentralized system. Like I said, interchangeably decentralized distributed, providing a scalable key value store without centralized coordination. What this guy here is, it's a gold, what's that gold mine? That's how they call it here. This guy, people sleep on this guy, right? What this guy is that imagine you have a store, a wallet that no matter the type of trouser, no matter the trouser that you're wearing, that wallet is always there. So if you have a wallet that is 500 naira, you can always forget your wallet and keep it at home. What if there is a mysterious wallet that once you just wear your trouser and step out, that wallet will appear there. And then when you want to spend your money, you see it there. You go to another trouser, you put on your wallet, that wallet is still there. That is what a distributed hash table is. So it gives you a key value store that is accessible anywhere. It replicates itself across all the nodes. What is this solving? This is solving availability, right? If you have a DHT and you have 1 million nodes, be rest assured that all of those nodes would have access to this DHT because the DHT itself replicates itself and it's just cool, right? So this guy, there is the DHT, and then there is this guy, Academia. You have multiple types of DHTs, right? But this particular guy, Academia, has some specific characteristics that makes things cooler, right? It is decentralized. It is efficient. It is a decentralized efficient lookup. It has a decentralized efficient lookup in P2P networks. It has an exclusive or based routing and then no central. So this is just technical gibberish, but what this means is that in a peer-to-peer network, if you know what a peer-to-peer network is, not when you enter Bybit, you want to exchange and you meet one malam or exchange, that's not P2P. P2P is saying that clients can connect to clients. If I want to send you in a true P2P network, if I want to send you money, the money does not hit Access Bank first before it gets you. It hits you and then gets back to me. I get the response. That's what the P2P network is, right? So the backbone of P2P is Academia DHT, right? It has result-based routing for fast node discovery. So when Academia wants to fetch 100 naira from your wallet, like let's go back to the scenario of a wallet. You have your wallet and your wallet is distributed across all your trousers. You need 100 naira. Academia can easily check which trouser the 100 naira is very fast. So it just goes to, trouser A, picks it up. It goes to trouser C, picks up the 100 naira. So the result-based routing helps you to discover which node has a particular value. Availability, fast availability, this guy. And then no central server already, which is more or less saying decentralized, no coordination, nobody is the orga here. You get? So everybody can act as they are. And when one is down, nobody really cares because the other guys can function well. That's what this beautiful guy is doing. Then it has specific operations. Ping, store, find node, find value. Ping is probably saying, okay, I am node A. I'm Academia DHT node A. Can I reach you, node B? Can I reach you? If I can reach you, then I can send requests to you. If I cannot reach you, get out. I'm going to someone else. So this guy actually helps us to maintain that relationship between other nodes, right? We have the store, which is putting the money into the wallet, pretty much. We have the find node, which is saying, which node is holding my 1,000 naira? Come here now, pretty much. Find value is saying, it's similar to find node, but instead of saying finding the node, instead of finding the trouser itself, it finds the money itself. So I need 100 naira, get me 100 naira. That's all. So these unique operations to Academia helps you to build, or rather build the logic behind having a system that's available once you are implementing the KDHT application, or when you're using KDHT application. This is how it actually looks like. All these guys are nodes connected together, and it's very easy to spin up. If you route a request here, it just does like a binary tree operation to check blah 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 blah, and you retrieve the information very quickly. Now, is KDHT alone sufficient? No. We already established that KDHT solves the problem with availability, but it doesn't solve which one? Thank you. Doesn't solve consistencies. So the original protocol for Academia has a lot of things, but it lacks mechanism for a robust data conflict resolution, which is consistency. While KDHT provides availability and partition tolerance, its eventual consistency model, which assumes true redundancy, leads to several challenges, which means it is not sufficient enough. I can solve AP, Can I solve C? No. Get out. I move on. What can I marry with this guy to ensure that if I bring them together, they can give us a solid result? So if we use this guy alone, these are some of the things that you'll be experiencing because concurrent writes. Imagine node A and node B. They both have their DHTs. And then suddenly there is a concurrent request, right? Someone sends you money. And because it's a distributed system, it can go to two people can send you money together. That's how it is, right? And let's say they send you money at the exact time. And then you now say, oh yeah, now 500 naira, let me store it in your KDHT. Because you're using this guy, KDHT will see it as one because I'm seeing 500 naira from two different nodes at the same time. It's probably one JAE and it stores it. 500 naira have disappeared. You are broke. You start going to your bank. This is person that builds the application, they will sack him. Problem. Now, this is the problem with using KDHT alone. For the reading consistency, it's like I said, because you have KDHT and then you can store your money multiple places, it means that when you try to find money, you could probably, because this guy has written nonsense, you'll be able to read nonsense. You want a 500 naira. In your mind, you have 1,000 naira. He said, okay, give me 500 naira because three people send 500 naira. This guy sends only one because he found only one. And then he started looking, where did my other money go? On that problem. Partition healing conflict. Because of the decentralized nature of the KDHT, when you have issues with network and then your network recovers, if they try to come back, let's say during that problem, somebody sent money to node A, someone sent money to node B, and they both have a 500 naira. By the time they recover from the issue and they try to merge, there'll be a problem because they will not be able to reconcile that money well. They don't know who is the original, which one is the view, right? Because, let's go back. This guy has written rubbish. This guy has read rubbish. This guy will reconcile rubbish. That's how it's going to be. The rubbish is going to cascade. Next one. Now, imagine this scenario. You have, which is mostly what I've explained. Consider a distributed counter, blah, 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 blah. You have two nodes, node A, node B. If a client sends 100 increment requests to node A and sends another one to node B concurrently at the same time, it means that two of them will process their requests locally because they're independent stuff. They're distributed, right? They will process it independently and then they'll have a final value of 100 because this one has 100, this one has 100. And then because two of them sees the same thing, it will tell you 100. But in the real sense, this guy is supposed to be 200 because someone sent to node A 100 times, someone sent to node B 100 times, and they're both independent. They're supposed to result to 200. But because of a naive implementation of a distributed counter, you'll be having these issues. Conflict-free replicated data types, CRDT. When I was going forward in my research, I found this guy. I've never heard this guy before. When I found this guy, I started saying, oh, this is what these people use. This is what these people use. Makes sense. Makes sense. But this tech, if you don't really research, you don't know about them. They are good stuff. You don't really know about them. So what is CRDT? CRDT is a data structure for distributed systems that allows replicas to be updated independently and concurrently without needing complex synchronization, automatically resolving this. From this already, this guy solves C. And then when you bring this guy and that guy, you solve a problem that has been in existence for over 50 years. The CAP theorem, right? So CRDTs are data structures, right? They are just a way to write your code in such a way that you are able to resolve conflicts automatically, right? So we have different types of these guys for different use cases. We have the counters, we have the offsets, we have the maps, we have we have the graphs, we have basically the way you know data structures today, your queue graphs, they have the CRDT equivalent, right? So if you're going to be doing a counter like the distributed counter we discussed, you'll be using this guy because he handles conflict well. Now, a CRDT must satisfy these three fundamental algebraic properties. And these are the reason why the CRDT behaved the way it behaves to me, right? Cumulatively, right? When you have two operations, A dot B, A must be B dot A. What this means is that if you have something from node A and you have another one from node B, when you put them together, they should be the same in the order when you have it from node B to node A. Very simple stuff. Associativity, right? Still the same thing. A, B, and C, no matter how you put it together, it must give you the same output. And idempotency, for any operation A dot A, when you do it again, it must be the same result. Technical gibberish. Well, let's move forward. So yeah, peer book, like I said, peer book was a proof of concept that I was building, but I am building to more or less tell people that this is very possible. And it is an expense tracker application, right? Imagine you guys want to plan a trip to Mauritius and you have planned this trip to Mauritius. You guys can create a group, and then for everything you guys spend, you can log it there. You can log the participants of who partook in this particular expense, who did not partake, and then these guys would help you organize all of those operations, right? So you don't even need to be online, because Peerbook is offline first, right? You don't need to be online. If you bought a platter of 500K and these three guys were part of it, you just log it in, you're the one that paid, and then three of them, you just put in the amount of money that they both. No, for now, this guy splits equally. So you just put three of them and then it breaks it down into three equal parts. So they are owing you because you are the one that paid. So this guy tracks it. And if he goes forward to load his own in another expense and then he puts in that value, it will automatically add yours and then reconcile it. Now, the problem, the best part of it is that he doesn't need to be connected to the internet. He can do it anytime, right? And when his application or his phone is connected back to the internet, he sends that request back. And then because of CRDT, he's able to reconcile that, oh, this guy at some point made this particular expense. So it resolves it without conflict. Even if it happened 1 million years ago, it can take that information and then it can reconcile it. This is what Peerbook is solving. And then we have different data types for Peerbook. We have the book members, we have the balances, we have the map to store the expenses, right? Yeah, this is just for the counter. This is what it looks like. We have the positive and negative. We have a mutual exclusion to handle risk conditions. So when a request comes to increment a value, this guy just counts. When a request comes to decrement the value, this guy counts, right? So they're both increments. And when you have both increments, this is saying if this guy was incremented 3 times and this guy was incremented 2 times, when you take out this from this, you have one. That's resolved the information, that particular issue. And then we have the increment, we have merge, which is the most important part of a CRDT. We have 2 types of CRDT. We have the state-based CRDT, we have the operation-based CRDT. For the state-based CRDT, you have merge, because when you change the state, you want to merge them together to get the updated state, right? But for operation-based CRDT, you don't have the merge. Whenever there is an operation, just broadcast that operation to the next node. The next node takes it in and then it syncs up, right? So it's a different approach. Yeah, this is the high-level sequence diagram for what we're doing at Peerbook. This is the user. He makes a request. He hits node 1. Node 1 puts it in the DHT. Node 2 can retrieve it from the DHT, which is the distributed hash table we talked about. And now, after they have both localized information, they are able to sync this and merge it with the CRDT. Magic. It's not magic. It's just bringing two things that are already existing together. So the CRDT KDST framework solves the CAP theorem, and with Peerbook, we're able to show people that this is possible. You can build a distributed system and not have to worry about the CAP theorem. Your application is going to be consistent, it's going to be available, and it's going to be partition tolerance, right? So this is a sequence diagram. It just shows what we're doing, how we're doing it. Yeah, which is high level. And then yes, real world applications of what we already have, right? Um, in your Google Sheets, right? Google Sheets, Google Docs. The reason why you are able to edit something and this person edits it on his own end and they don't, it's not still Yamayama, it's not gibberish, it's because Google is applying CRDT under the hood to resolve this editing actions, right? It's an operation based CRDT, right? So you edit something, you write my name is me on my laptop because I have access to that Google Doc. I remove is you can see that I have removed is beautiful stuff, right? So CRDT under the hood. Distributed counters, we have CRDT under the hood also. P2P file sharing, if you use torrents, all of it that used to go and you're laughing. You should go and download games. You're a pirate. All of you that download games from BitTorrent or movies, right? You will see that BitTorrent is actually a P2P application. The application where you're downloading is not in one place, right? It is broken down across different people. That's how torrenting works, right? So under the hood, BitTorrent uses Kademlia DHT to serve and store all of this information in a distributed hash table so that when you request for it, you can easily serve it without issue. It's not staying in one person's computer, and that's why it is a very good thing, right? Distributed file storage. We have Swarm from Ethereum. If you're a blockchain person and you're in the ETH community, probably I've heard of Swarm. The protocol is for storing things on the blockchain network, right? Specifically to Ethereum. And because of it is decentralized, there is no central coordination. What happens under the hood? ADHT. Same with shopping carts. We have CRDT here. And then for gaming leaderboard, we have both CRDT and KDHT used. So if you bring those two together, you are already solving a problem that has existed for a long time. And that's what my framework is proposing and the research paper. Yeah, so challenges and future directions. When did I write this? I wrote it, don't worry. Not necessarily Indomie because it's not easy. It's not easy. The research and the application of this stuff requires some sort of technicality, right? You need to understand some things at a lower level, right? So complexity in designing the CRDT requires some sort of mathematical knowledge. When I was showing you commutative, after you said that they're basically mathematics dot operations, right? So you need to understand that there are some mathematics involved in it. Storage. When you not keep storing things in a distributed hash table, you would need to have somewhere that you can accommodate all of these things because the size will keep growing, right? And when you see something that has an increased size, you would obviously need to start paying for storage space and all of that. And then adoption is still niche, so you don't really have a lot of resource out there. And that's why my research paper is out there. Yeah, this is Peerbooks repo. You can scan it and my research resource, my research paper, everything I'm doing, you will see them in this QR code. So you can just take your time and scan. I'll go back. 3, 2, 1. I'm going to go back. Oh, thank you. So yeah, that's going to be all. I don't know if I have bored you guys, but I feel like I've said some things. So thank you very much. Any question? Yeah, you'd have your applications orchestrated either behind what's it called? A gateway or behind Nginx is called what? Oops. Behind a gateway, behind the CDN, behind the so you have all of these guys that help you to orchestrate your distributed system. And by default, they already apply partition tolerance in such a way that when your nodes should still communicate to each other, right? So when a node is down, it will stop to detach itself from that particular node, right? So the problem with partition tolerance is that when there are network issues, it wants to be able to still reach the second node that might be down, but not necessarily route requests to that node, right? So load balancer. What's a load balancer? So yes, you have all of these guys today that when you orchestrate your applications behind them, automatically they help you to achieve partition tolerance. Yes. Does that answer your question? All right. Any more question? All right. The nature of the application you're building would help you or guide you to choosing which of these guys, right? Now, when you move up when you in your software engineering career, right, as a junior, mid-level, intermediate, senior, solution architect, you get to a point where you are able to make trade-offs. That's what they are, trade-offs. It's not uncommon that things would fail. Things would fail, right? So you should be able to build or choose which one you want to fail. Now, I've primarily worked in the fintech, right? And because we're working with money, I cannot I cannot choose consistency to fail for any reason, right? Because when working with monetary values, we want to ensure that this particular value is the accurate value anywhere at any time, right? And because I'm choosing consistency, I am starving or I'm letting go availability, right? That's why I'm able to say, well, because I'm having an issue, instead of me showing you something that is not accurate, let me leave my accurate data, but I'm not going to allow you come and look at it. That's what is happening. So I am starving availability and I'm ensuring that things are consistent with my system. I don't want to have people money disappearing or having negative balances or something that is not real. So Facebook, Meta, and all of those guys, they will be able to staff consistency. And that is what I mean by Twitter, for instance. When Twitter is down, you can still access the homepage, but you will not see any recent information. You will not see any recent data. But you are accessing the application. You can still scroll your old tweets, the old tweets on the TL, right? You can still scroll. What are they doing? They are starving consistency and they are ensuring that the system is available for you to reach, right? So the consistency here for them doesn't really hurt. They're not a fintech company. They're just showing you what someone has tweeted a long time ago. And there is no real negative impact if they're serving you something from 2 hours ago. Do they care? No. So they have chosen to pick availability and partition tolerance because consistency wouldn't hurt. So a fintech company, trust me, if they don't choose consistency, man, all up and pull everybody. Police will carry everybody in the company. Yeah, that's just it. Thank you. Okay, I have a question. I think I did. The bank has chosen to cache their information and ensure that you can still access it, right? So you're opening the application instead of it to go to get the updated information because maybe that place have been born in or something is happening. They're able to serve you your balance from a local storage so that when you now refresh, you can now get the updated value. So in this term, they've chosen to serve you they've chosen to be more available to you than to show you something that's not consistent. Well, it happened in me. Whoever wrote that line of code, I was still query because you cannot allow me to access the application, show me something that is not correct, and then force me to refresh. But I mean, everybody to their own. So they probably want you to access other part of the application, and then you already said by default, you already know that what you're saying is not your account banner. So it's probably a long problem that is happening on their end that they are probably trying to fix. But yeah, kudos to everybody involved. Yeah. Any more questions? If we go back to the reason why we started building a distributed system is so that we can have P. Now, a system that is not distributed automatically will be consistent and it will be available. And when I mean to be available, because it is in a single place, you can only serve that particular until maybe that application is down, right? So partition tolerance automatically becomes a constant because when you start deploying multiple nodes to make your system available and distributed, because the purpose of having a distributed system is not just for the availability sake, it's for responsiveness generally. It makes things faster because your application is not just bottled up in one place. It's broken down into multiple places. So if this guy is having issues, you can serve from this guy and all of that. So P becomes a constant because you would try to ensure that whenever there is a network failure. So when you talk about partition instance, partition tolerance, I'm talking about network. And not network with your maybe mobile data. I'm talking about network in the system that the nodes are communicating, right? So if there is probably an outage with AWS that is serving those nodes, you start having partition tolerances, right? So you start having partition failures or network failures. So you want to ensure that when there are such issues, your nodes can still communicate to each other, right? And when they communicate to each other, even if one node is down, it shouldn't be a problem, right? So they are trying to stop the constant, right? People by default, the tools that help us to orchestrate this said this guy is the constant. And to people who understand distributed system from the grass level, they know that if partition tolerance is not a constant, it is a bigger problem because when AWS goes down, the whole of Twitter, in fact, nothing will show. That's because all the nodes can't communicate and then they would cascade and crash. So that's why they made partition tolerance a constant. And then because people can choose to take trade-offs from the other two and not get really hot, that those guys are now the options for discussion. That's thank you very much.